All right, guys, this is Mr. Hickman. I'm back with you with a lesson on air masses today. And just the PowerPoint that we covered in class, something I got off the internet, and I'm just kind of talk you through this real quick and give you a brief rundown on air masses so that you'll be able to study for it. Air mass starts with humidity. There's two characteristics that really define an air mass, and we'll talk about that here in just a minute, right? Air. A body of air that has the same temperature and humidity throughout. So that is what an air mass is. A body of air that has the same temperature and humidity throughout. Now, humidity and temperature. Don't really have to go into temperature, I don't think. I mean, we kind of all know when it's hot and when it's cold and how we go about judging that and the mechanical way we go about determining what the temperature is. So we kind of got that down, but let's talk about humidity. Humidity, the relative measure of the amount of water vapor in the air. So we look at water vapor, we use a psychrometer. That's a tool that measures humidity, measures how many water particles per million, per billion, per thousand that we have in the air. Water vapor affects the density of air. That is a very important thing to know. Water vapor affects the density. The more water in the air, the more water molecules in the air, the denser the air mass is going to be. Okay? Cold air is heavier than warm air. Cold air can hold more water than warm air can. So water vapor, can more of it in cold air than in warm air. Just basic physics. Okay, air masses, we talked about what an air mass is. How do they form? They sit over an area of land or water for a period of time, and it takes on the characteristics of the land or water beneath it. So it would be easy to think that if an air mass set over water, it's going to accumulate a lot of water vapor. Over land, it won't acquire so much water vapor because it's over land. It's just not sitting over water. Temperature and humidity are the two things, once again, that we're talking about that makes an air mass what it is. Okay? Location. Air masses over the equator have higher temperatures. Air masses over the polar regions have lower temperatures. That is kind of pretty easy to think about. Polar regions are cold. The air that sits in that area is going to be colder. Masses over the equator. The equator is warm. It's tropical. So you'll have higher temperatures. Air masses over water have high humidity. Air masses over land, lower humidity. Talked about that a minute ago. They form in areas with little wind. If they don't set over an area for very long, then they don't have time to get those characteristics from the land. Kind of like you pull your Coca-Cola out of the refrigerator, you set it on the table, it doesn't immediately get warm. It doesn't immediately change to room temperature. It takes some time. Just like an air mass, it takes some time to be over the area before it gets the characteristics of that area. Okay, we label these air masses in two different ways based on how much humidity they have. You have maritime, which is an air mass that is over water, and continental if that air mass is over land. That tells us whether it's going to be humid or whether it's going to be dry. Now, we have these 5 different types of air masses, and we're going to get to where those are located, but let's start out with this. We name them small m, capital T, small c, capital T, small m, capital P, small c, capital P, small c, capital A. Maritime tropical, continental tropical, maritime polar, continental Arctic. Then you should know, and it should come pretty easy to you, that Arctic would be colder than polar. Okay? And so, ice-capped poles of the Earth are all going to be continental Arctic. Super cold above a solid mass, which is ice. And we call it continental because it's not water. It's not water in the fashion of ocean. Okay, so maritime, ocean, tropical, warm, continental, land, tropical, warm, maritime, ocean, polar, cold, continental, land, polar, cold, continental, land, Arctic, very cold. These are where these regions are found in the northern hemisphere. You can see the maritime, tropical, down around the equator. Notice to the right, you see that maritime, tropical green area. That is where all of our hurricanes come from. The water gets warm and starts a lot of storms in that area. Just above that is the maritime polar. Then you have the dark blue in the center. That is the continental polar. And you have a little area over around California area. That is the continental tropical. And then across the very top, you have where the ice cap is at, you have continental Arctic. So you can see where those guys are located at. Okay. Once again, I kind of went over this already. Maritime, warm, continental, tropical is warm. So maritime, moist, continental, dry, tropical, polar, Arctic. So warm, cold, super cold. And then you have moist for tropical, moist for maritime, dry for continental, and you see how that is up on the board there. Okay, we've got convection here. Convection. We talked about that in another video, but we're going to play right in here real quick. We got to talk about this because it's so important. Warm air rises, cold air moves in to replace it. A circular pattern is formed. Convection causes the air to move and the ocean currents to form. Ocean currents and air mass movement is a lot of convection goes on to make this all occur. Warm air, less dense, rises up. Cool air, denser, stays down low. But once that cool air gets over a hot land mass and starts to warm up, the clouds form and all the water gets bound up in clouds and stuff, and then the actual air part of it starts moving around. You see that sometimes in a summer storm when you get those big thunderheads where the ground is warming up the air. The molecules form clouds, and the clouds shoot straight up into the atmosphere, and you can just see them going straight up. Air pressure. The two things in red, most important to know. Warm, less dense air has lower pressure. Cool, dense air has higher pressure. Very important things to know. 5 types of air masses. Y'all be able to name them now. I'll give you a couple of hints. You got continental, you got maritime, you've got tropical, and you've got polar, and the last one you have Arctic. So mix those terms together and come up with your 5 types of air masses, and how do these different air masses form, and just think about where they're located at. Got you under 10 minutes. Good luck to you guys. Test coming up over all this material. Good luck to you. Peace out.